As DRD, we produce gold from waste, being waste rock dumps.
DRD Gold and its subsidiary Ergo is an environmental cleanup company. We effectively take the mining waste of the past and we're processing that through the Ergo facility and we're placing it on world-class large tailings facilities. In our case, Brakpan, which is soon to be sort of extended with a Withok extension and possibly another bigger tailings dam coming into operation. But we want to do this as responsible as possible.
The first problem that we experienced was that if there's an interruption to the power to Ergo for a few seconds, it means that the plant would be standing for at least 4 hours, and it would take us a minimum of 4 hours to get the production back up. For that reason, we decided to venture down the route of installing a solar and battery system. Started looking at the batteries and realized, well, batteries technology has now developed to the point that you can actually produce it industrially. And when we started looking at the design of that, we then said, okay, well, how do we essentially charge the batteries? And that's when solar again came to the fore.
The solar PV plant was effectively executed in 2 phases. Whereby in the first phase we targeted a 20 megawatt solar installation only. Construction on that started in February of 23 with the first commissioning around about March of 24. The second phase, which was another 40 megawatts of power to be generated by solar PV, and that came online around about August, September of 2024. Now, part of the second phase was also the rollout of a BESS, or better known as a battery energy storage system, to about 187 odd megawatt hours that was installed to provide 160 megawatt hours available at any one point in time.
The reason we ended up at these size batteries is in order for us to shut down the plant in a controlled manner, we need at least 2 hours of battery capacity.
All these panels are dedicated in strings. This has tracking devices which enable us to track from 6 o'clock in the morning till 6 o'clock in the evening, which allows maximum irradiation on these panels and really give the effective output which we require in the plant.
Then the second component was to hybridize it with the battery system. The battery system is the base. It's a 40 megawatt and an 87 megawatt hour batteries. The system that we chose is the NEDEC system. It is a very, very good system. It's very advanced with continued R&D, even in the process that we were here. So we've already achieved black start capabilities. So our ramp up time, if you can believe on the batteries, is 1 megawatt a second. Gives us a lot of ability to tweak and to push and pull and to optimize. And then on grid connection to grid disconnect to going into island mode, milliseconds. So these are the advantages of putting the two together.
Ergo at that stage had 2 feeds. It had 1 feed into the Brakpan tailings dam and 1 feed into the Ergo plant from Ekurhuleni. The Brakpan tailings feed was at 11 kV and the Ergo feed was at 6 kV. We then decided to upgrade the Brakpan feed to an Incomer 88 kV line, constructed a Eskom substation for 88 kV Incomer, transferring that power then to a consumer sub, which is our consumer sub at 88 kV, and then stepping that down to 22 kV.
The demand of the Ergo plant is around 14 megawatts and at Brakpan tailings 7 megawatt. The power is exported along 22 kV overhead lines, which were built at 33 kV. These overhead lines formed part of the project, as well as an upgrade in the Ergo plant. The Ergo plant was fed from an Eskom supply and is now currently being fed from the 2 new overhead lines. Furthermore, we've got an additional 2 overhead lines at 22 kV feeding at Brakpan tailings. This allows for successful export into the grid. From June of 2024 to date, we have produced 47 gigawatt hours.
During this period of construction, we peaked at Around about 320 local employees from the local communities and the immediate surrounds. Middle 2024, from where it's now ramped down again to about 60 odd employees local and on a permanent basis. 83 million rand was spent on local small suppliers, and of that, 9 of these guys, we've now formally also sort of developed them as SMMEs, and they are also on the Ergo vendors list. So the solar plant consists of 132,500 panels, then feed through 188 inverters. These are 350 kilowatt units, and those inverters then feed through into 42 BESS or battery energy storage containers. Each of these containers has got 96 lithium-ion batteries in them.
This is the first project that has got BESS, PV, and a load behind the grid and is exporting into the grid.
Another advantage of the batteries is that we can arbitrage. This means that we charge the batteries during an off-peak period when electricity is at its cheapest, and then we discharge the batteries when electricity is at its peak.
And by doing that, we can reduce our costs significantly, especially if we can then utilize and store all of this PV energy in a battery and then release it later on during the night time. The idea is then to then run the circuit where you start up in the morning on peak period off the batteries. Once the sun is up, the solar takes over. Plant then runs off the solar, and at the same time you also charge your batteries from the solar. Going into the night time between 6 and 9, you then discharge your batteries again, which is that peak period, and then after 9 o'clock during night time you then charge the batteries with off-peak power from the grid.
Financial modelling certainly would indicate that there's a very significant sort of reduction in operating cost.
All of this really is what DRD Gold stands for, sustainability while mining. We can now mine at a reduced electrical rate as well as decarbonize.
And this is why we embarked on this project. As one of the benefits, we reduce our carbon footprint, our total usage, by about 52% once in full operation from this process, which is a significant reduction and utilization of our carbon footprint. And it provides not only a circular economy, but it benefits everybody. All of a sudden, you're utilizing cleaning land which was previously sterilized, and you're making that land available for development. You taking a point source of pollution away in terms of dust, and you're consolidating that into a world-class deposition site, which is the Brakpan Tailings Dam.
I'm very proud to say that this project's avoided carbon tons is 186,840 tons CO2e, which I think is also a great, brilliant plus for the mine, because the mine can use that mitigation to offset those elements that they cannot mitigate.
From a strategic perspective, there were a few reasons why we started with the project. The first one is to make sure that we have continuous production at Ergo. Secondly, there's also the cost. If you break down our cost curve, our operating cost, electricity makes up the third largest single cost for our operations. Between 14 and 17% of our total operating cost comes from electricity. So if you can reduce your electricity cost, you've got a direct impact on your bottom line. And the third reason that we did this is due to our carbon footprint. By implementing this program and this project, we've been able to reduce our existing footprint by approximately 52%. For every rand per ton that we can reduce our operating costs, we can then also in future be able to mine additional resources at a lower head grade because our input cost is so much lower. So it provides us flexibility, not only from immediate operating and increase in margin, but also in future being able to mine lower grades into the plant.